Westgate Towers in Canterbury, England. I did a little survey in which I checked how many vehicles were passing through the tower in a 1-hour interval for a 30-hour period. I organised the numbers of vehicles in ascending order, and then I made a grouped frequency table showing how many times vehicles within a certain class were passing through. Now I could show this on a bar chart. Or I could show it like this. The big difference between this and the bar chart is that the horizontal axis has a scale and is not made up of discrete values. In that example, each of the intervals was of the same size. But supposing I varied the size of the intervals, I might want to do this because I'm less interested in the very small or the very large values, for example. When I do this, the diagram doesn't look proportionate. It looks like the larger values are appearing much too much, and so are the smaller ones. To remedy this, we need something called the frequency density, which is the frequency divided by the class width. And sure enough, the diagram looks much more realistic. Though of course the vertical axis is now frequency density and not frequency. This means that the areas of the blocks actually correspond to frequency. This type of diagram is called a histogram. One of the things that you can do using a histogram is to find the numbers of individuals within a certain interval. As I've shown here, this would then correspond to the area of A plus the area of B. A good way to memorize the relationship between frequency density, frequency and class width is by means of this little triangle. If you want the frequency density, divide the frequency by the class width. If you want the frequency, multiply the frequency density by the class width. And if you wanted the class width, divide the frequency by the frequency density.